Hey guys. All right, so we are going to um, what's presentation? Going to go over a couple of problems on friction, for a little extra practice, because I know some of you have asked for that. So not a problem. Wrote up a couple problems, and basically we will solve them. Just so you know, these directions right here are exactly what you'll see on the quiz. Draw a free body diagram for each problem. Be sure to give a reason for why you think the object slides or why it does not. I'll explain what that means as we go through the problems. So let's just look over on question 1. Let's get right into it. I'm just going to use this space over here. 2,000 Newton car. Right away, I'm just going to start free body diagram. I have to. It says right here, draw a free body diagram. So 2,000 Newton car, that is my force of gravity. That's a big force. That's why I drew it big. So 2,000 newtons. Since it's going to be on the road means that the normal force is also 2,000 newtons. I can set that up. I haven't even read the whole problem, and I'm already setting up my free body diagram. Where the coefficients of friction are 0.4 static. So that's my mu s is 0.4. My kinetic, mu k, is 0.2. What force of friction will be present if you push horizontally westward with 600 newtons? Westward, 600. If I'm pushing, that's an applied force. That's Fa. Is 600 newtons. So, the first thing I have to check is this enough to break my static friction force? So I've got to calculate my FFS maximum. And my FFS maximum is the static friction times the normal force. Or static friction coefficient times the normal force, I should say. So my static friction coefficient is 0.4 times my normal force, 2,000. So to me, 0.4 times 2,000 is, so the maximum of my static friction, it can push back a maximum of up to 800 newtons. So I'm pushing with 600. 600 is our check. Our check is the applied force greater than FFS max. So is the applied force greater than FFS max? Is 600, we don't have to, I mean, you know this right away, but I'm just going to do it out formally. Is 600 greater than 800? Obviously, this is a false statement. Use red for effect. It is a false statement, so it's not true. So our answer is no. When our answer is no to this question, is FA greater than FFS max? If the answer is no, then it means we are not sliding. So if we're not sliding, what that means is that our force of static friction, which is anywhere in the range of 0 to FFS max, capitalize, FFS max, anywhere in the range, if it's not sliding, then our FFS is equal to our applied force. By Newton's third law, it's going to interact forward and back. So what is our magnitude? Our magnitude is going to be the same as our applied force on our free body diagram. Our magnitude and direction, it's going to be the opposite direction of what we're pushing, is going to be 600 newtons. It's a static friction force. And we know, just to write it out, FFS is 600 newtons east. We're pushing west. Friction acts opposite of what we're doing, so it's 600 newtons east. So that's question 1. Question 2. Scroll up so we can see. So question 2. 50 kilogram crate. Right now, there's no mass that I want to deal with. Sorry, we have mass. I don't want to deal with mass. So mass to weight, I'm going to multiply by 9.8. So 50 times 9.8 equals my weight. 50 times 9.8 is 490. So on my free body diagram, which I need, I've got a weight of 490 newtons. Same thing, on a floor, my normal force is also 490 newtons. We are going to be doing problems where these two aren't the same, but that is not for this quiz. Coefficients of friction, 0.3 static, 0.1 kinetic, so that's my mu s and my mu k, respectively. What force will it take to get the crate moving? To get the crate moving, that means that it's currently at rest. We also said right up here it's at rest. So to get the crate moving, I have to push a little harder than FFS maximum. So what is my FFS maximum? Well, it's mu s times the normal force. So 0.3 times 490. 0.3 times 490 is 147. So the maximum my floor could push back is 147 newtons. So in order to make it move, I have to push with an applied force just a little bit greater. Can't be exactly 147. If it's 147, then the floor can match that. So it has to be something greater than 147 newtons. Sorry, I blocked it out a little bit. Once moving, how much force will it take to keep it moving at a constant speed? Well, constant speed, now it is moving. Whenever we're moving, we deal with force of kinetic friction. By the way, up here, my applied force, you can put greater than on a free body diagram because this isn't a very distinct problem. It doesn't say what direction, so I usually put, well, it should be coming from the center. I usually put the applied force to the right, unless otherwise forced to. So that's what I would do. 147 as well. So static friction force to the left, 147, as long as my applied force is greater than 147, then I got it to move. Now it's moving. As soon as I move it, I immediately jump down to kinetic friction. Kinetic friction, there's only one value. It's always equals. There's no greater thans or anything like that, times the normal force. So 0.1 times 490, and I can do that one in my head. That's just 49. So once it's moving, my applied force has to match. Constant speed is my keyword here. Constant speed says that F net is 0 because A is 0. My acceleration is 0. Constant speed, I'm not changing it. So, free body diagram, you would have the same, I'm just for sake of time, you'd have the same normal force, same force of gravity. But the force of friction that we're dealing with is FFK. It's going to be 49 newtons. To have a net force of 0, I have to have an applied force not greater than, like we did in part A, an applied force exactly equal to 49 newtons. We have to balance out the friction. So that's that. Question 3. So, question 3. 1400 Newton wagon at rest on a carpeted floor. Rest. So we know we have to look at static friction first. If the coefficients of friction are 0.6 static, 0.4 kinetic, what will happen if you push horizontally with 815? So, my normal force is given, 1400 newtons, because normal force in this case is the same as gravity, and the gravity is 1400 newtons. Start building a free body diagram. 1400 equals Fg. Cheese it. Fn is also 1400. Alright, coefficients of friction are 0.6 static. So I'm going to get my FFS max, and I'm going to get my FFK. FFS max, 0.6 times 1400. FFK, just right away, 0.4 times 1400. 0.6 times 1400. 0.6 is 840. 840 newtons. FFK, 0.4 times 1400, 560 newtons. All right. So if I'm pushing with 815, I got to do my check. Right now it's at rest. I got to see, is FA greater than FFS max? In this case, once again, it is not. It's supposed to be red. It is not. So once again, I am still not moving because, and what will happen, I want to have this because if you remember, text is still going to be there. If you remember, be sure, it says right here, be sure to give a reason for why you think the object slides or not. So it is not going to slide. Try to get it back to the same spot. It is not going to slide because the applied force, you want to just sort of write it out, applied force is not greater than FFS max. Or you could write it out as because 815 is not greater than 840. Either way would work. So I want to do one other sample problem real quick. What if we had it as, what if we pushed horizontally with 915? So this is like another problem. You would have 4 problems on the quiz. Those are similar to the first 3 you would have. The 4th problem would be one where you are pushing enough to get it to accelerate. So we are pushing hard enough in this case now. So let's erase all this. We are pushing with 915. So from earlier, our FFS max was 840. FFK was 560. So our check, free body diagram would still be over there. Our check, we are moving because 915 is greater than 840. Our applied force is greater than the maximum static friction. So as soon as we're moving, we jump to our kinetic friction force. So free body diagram. Looking at it to find the net force. Our force of gravity hadn't changed, it's still 1400. Our normal force hasn't changed, that's still 1400. Our applied force, we're still pushing with 915. And our force of friction, when we're moving, now we are moving, we already determined that with our test, that our force of friction is going to be our kinetic friction, that is our moving friction value. It's going to be 560 newtons. So, to figure out the acceleration, it doesn't specifically say, but on like part B it would. To figure out the acceleration, A, by Newton's second law, it's net force divided by mass. So, we have the ability to find the net force through our free body diagram. The 1400 cancels with the 1400. 915 and 560, they're in opposite directions, so our net force is going to be positive 915 minus 560. 915 minus 560 is 355, so our net force is equal to 355 to the right, divided by our mass we get from our normal force. So normal force 14, well, from our weight, aka the normal force, is 1400 divided by 9.8. So our mass is 142.86 kilograms. 142.86. So 355 divided by 142.86 gives us our acceleration of A equals 2.48 meters per second squared. And in this case, it would be to the right. All right, so that's basically all there is to the quiz. There'll be a couple of multiple choice, but we will go over those before the quiz. All right, thanks.